Good afternoon. Here's pre-calculus practice test number 1, covering chapters 1 and 2. Here's chapter 1, functions, 2.5 complex numbers, 2.6 quadratic functions, and this is the second part. So, square root property. According to this principle, if x squared equals a, where a is a real number, x is plus minus square root of a. Simple example, x squared is 49, x is plus minus 7. Solving quadratic equations. The general form is ax squared plus bx plus c equal to 0 by completing this square. So how do we do that? First, what is a perfect square? A perfect square trinomial is a trinomial that can be expressed as the square of a binomial. For example, x squared minus 10x plus 25 is x minus 5 squared, quantity square. Note that in every perfect square trinomial, the constant is the square of 1/2 the coefficient of the x term. If you look at the x term, the coefficient is negative 10. Divided by 2, negative 5. Square it, 25. That's how we get that, p over 2a, quantity squared. So, how do we solve by completing this square? If it's x squared plus bx plus c, we add half of this quantity squared, b over 2 quantity squared. We get this one. Simplify and solve by the square root property. The quadratic formula that is proved using the completing the square method. A squared plus bx plus c equal to 0. X is minus b plus minus the square root of b squared minus 4ac over 2a. This b squared minus 4ac plays an important role. It's called the discriminant. If it's positive, we have two distinct real solutions. The solution will be rational if the discriminant is a perfect square and irrational otherwise. So, b squared minus 4ac, okay? If it's positive, we have two real solutions, and more specifically, if it's a perfect square, two rational numbers, which means we could have factored in the first place. If it's 0, one real solution, and if it's negative, no real solutions or two complex solutions in the form of a plus minus bi. If b squared minus 4ac is a perfect square number, then this can be factored. So a lot of information here. Let's look at some examples to make some sense out of this. We want to solve this by completing the square. The first step is to move the 7. And bear in mind a is 1. So b is 6 divided by 2 is 3, squared is 9. We are going to add the 9 to both sides. Now, when you do that, the left side is always x and b over 2, including the sign. So x plus 3, quantity squared. The right side, you add up the two numbers, we end up with 2. So the square root property says this, x plus 3 is plus minus square root of 2. And you move this, and there are two answers. X is minus 3 plus minus square root of 2. Plus minus means minus 3 plus square root of 2 and minus 3 minus square root of 2. Two answers. Two z squared minus 7z minus we need to do a couple of things. We're going to move the constant. We make it positive 4 on the other side. And we want to make sure a is 1. So divide both sides by 2. Divide this one by 2, you get z squared. This one minus 7 half z, this one is 2. Divide both sides by 2. Now, what is b? Negative 7 halves. Now, you have to divide this by 2. How do you divide a fraction by 2? You multiply the denominator by it. You get minus 7 over 4. You're going to square that. You get 49 over 60. Add it to both sides. So what happens? The left side will always be the variable x, y, z, in this case z, and b over 2. So that means minus 7/4 quantity squared. The right side, add up those two numbers. 2 times 16, 32, and 49 adds up to 81. So z minus 7 over 4 is plus minus the square root of 81 over 16. This is 9 over 4. We are going to add 7/4 to both sides. 7 minus 9 and 7 plus 9 over 4. So 7 minus 9 is negative 2 over 4, negative 1/2, plus 9 is 16 over 4 over 4. 7 minus 9 over 4, 7 plus 9 over 4. There you have it. All right. Solve by the quadratic formula simply means use that, which means we have to put it in the standard form using moving the 5 to the left. A is 2, B is 4, C is negative 5. Plug into this. So we have minus 4, this is 16. Plus 40, get 56. 56 is the product of 4 and 14. Why do I write it in this fashion? Because I want to bring the 4 out. Now, I've seen students getting rid of the 4, which is wrong. You have a common factor of 2. The final answer is negative 2 plus 1 is the square root of 14 over 2. Seven x squared plus 4x plus 3 equals 0. And we write A is 7, B is 4, C is 3. Now we're going to plug in. Minus B, that means minus 4, plus minus a squared of B squared, that means 4 squared, minus 4 times A, which is 7, C, which is 3, and the product of 4 times 7, 28 times 3, 84, results in 16 minus 84 being negative 68. And what we have here, we have a negative sign. We also have 4 times 17. Again, why 4? We are looking for the highest perfect square number that is a factor of 60. So we can take the 2 out, and the negative we represented with an I outside. That's why sometimes they put it in between, because one may be under the assumption is that I is inside the radical sign, which is not the case. Now we factor the 2 out, we get 2 times negative 2 plus minus square root of 17i. It simplifies to negative 2 plus minus the square root of 17i over 7. And again, if it helps, put the I in front so we don't mix them up. Okay, everybody? So solve by the quadratic formula. I'm going to continue in this case, 2 plus 4 over x minus 1 over x squared. As you can see, it's a rational equation. There are different ways of solving them. One way is to multiply both sides by LCD, and as you can see, LCD is x squared. So we're going to multiply by that. Needless to say, x can't be 0 because we can't divide by 0. So if we multiply by x squared, we get 2x squared plus 4x minus 1. The right side, 0 times anything is 0 times x squared. So now we are back in business where a is 2, b is 4, c is negative 1. Plug in. Minus if b is minus 4 plus minus the square root of b squared, that means 4 squared minus 4 times a, which is 2, times c, which is negative 1. Negative times negative is positive. 24. Again, 24 happened to be 4 times 6. 4 comes out as 2. Again, we're going to factor out the 2. And The answer is minus 2 plus minus square root of 6 over 2. Now, it's important not to be under the assumption we can cross out the 4s or the 2s here. That's why if you make up two fractions, this over this is -1 and this over this remains. Perhaps if you put it in this format, you can see that you can't get rid of the 2 because 2 is not a common factor for the numerator. We want to solve the absolute value equality, absolute value of 4x minus 7 equals 5. So what is the process? Whenever you want to solve an absolute equality or inequality, the first step is to isolate the absolute value so that the equation is in the form of, if it's an equation, absolute value of x plus b equals c. So if it's an inequality, would be less than or greater than, but the first step is identical for all. So for the equation, if c is negative, then there's no solution because absolute value, worst case scenario is 0. Remember, it's distance from 0. So if it's negative, there's no solution. If it's positive, then it has two answers. We proceed to the next step. Number 2, ax plus b. Drop the absolute value equals c and drop the absolute value equals negative c and solve both equations and check. Because this number is 5, we're going to drop the absolute value plus minus 5. We move the 7 to make it plus 7 to the other side, and we divide both by 4. So we have 7 minus 5, which is 2 over 4 or 1/2, or 7 plus 5, which is 12 over 4 or 3. So what happens in this case? First and foremost, isolate. This is not isolated. So don't touch the absolute value. Move the plus 1. Subtract it from 3. Now that it's isolated and it's positive, you make up two equations. 2x minus 5 is plus minus 2. Move negative 5 to the right, make it positive, and divide by 2. Five minus 2, 3/2. 5 plus 2, 7/2. And we are done. Solve each inequality, graph the solution set, and write the solution set in interval notation, absolute value of 2x plus 3 less than 7. So what is the process, everybody, in general? If absolute value of x is less than a, and a is positive, then x is sandwiched between negative and positive a. If absolute value of x is less than a and a is negative, there is no solution. This is positive. Yes. So drop the absolute value sandwich between negative and positive 7. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . You want to move the 3, that means you are going to subtract 3 from all 3 sides. This is negative 10, this is 2x, this is positive 4. Divide everything by 2, x is between negative 5 and 2. This is an inequality solution. In interval notation, parentheses, negative 5 to 2. If you have the equality, we go with brackets. On a number line, we look at negative 5 and 2. The endpoints are not included. So there are 2 ways to show that. Either you use parentheses, that means the endpoint negative 5 and then endpoint 2 is not included, or you can go with a hole. Everything in between is fine, but there is a hole at the end. If the endpoints are included, it's a solid. What about this one? Square root of 5x plus 7 plus 10 equal, less than or equal to 4. Again, the first step is to isolate. Don't touch the absolute value. Move the 10. And absolute value of 5x plus 7 less than or equal to negative number, any number which is negative. No solutions. So, a quick recap. Number 1, isolate the absolute value. Don't change anything. Number 2, look at the number on the other side. In the case of equality, and less than, both of them, there is no solution if that number is negative, okay? What about this one? Again, here's the methodology. If absolute value of x is larger than a and a is positive, either x is less than negative a or x is larger than a. If absolute value of x is larger than a and a is negative, put a negative number, any negative number. Absolute value in worst case scenario is 0, and 0 is larger than negative number. So it's all real numbers. Okay. So how do you deal with that? Isolate it first. Subtract 3 from both sides. Divide by 2. It's completely isolated. And again, notice I haven't touched the absolute value yet. Now that it's completely isolated, x is less than negative a. That means this is less than negative 5, or x is larger than a. This thing is larger than 5. And of course, it has the equal. It happened to have the equality because originally it had it. Let's solve the 2 inequalities. So we are going to move this. The first one, 3x is less than or equal to negative 4. The second one, larger than or equal to 6. Divide by number 3. X is less than or equal to negative 4/3, or x is larger than or equal to 2. Pretty straightforward. Now, in an interval notation format, this means x is from negative infinity to negative 4/3. This means x is from 2 to infinity, endpoints included brackets. And because of the OR statement, we go with the union of events. Minus infinity to minus 4/3 bracket, union, bracket 2 to infinity. By the way, negative and positive infinity are both concepts, not numbers. They will always take parentheses. So on a number line, we have this answer. So just to make sure we understand, here's the number line, everybody. I want to make sure. Here's 0. Then we have 1 and 2 and 3. So this is 2, -1, -2. So from number 2, we can use bracket and everything to the right of it. Negative 4/3, that means -1 and 4/3, -1 and 1/3, everything to the left of it. Or you can use a solid point. That means you may use a solid point here. This is the number line, okay? That's how you put that. Let me erase my work so I can show you the next example. So I hope everybody's clear. So this is the graph in essence, okay? Everything here, and the endpoint is equal. Absolute value of 5x plus 7 plus 10 is larger than or equal to 4. We have to move this and becomes negative. And as we mentioned, if a is less than 0, the solution is all real numbers. So very straightforward. We want to solve and check square root of 2x plus 1 plus 7 equals x. The first step is similar to what we did as far as absolute value equality is concerned. That means isolate, that means move the 7. So as you move the 7, that means you subtract it. Now that the root is completely isolated, in this case square root, you are going to raise it to an appropriate power, in this case to the power of 2, both sides. So this comes out, this becomes x squared minus 14x plus 49. Let's just actually write this. A plus minus b squared. It's a squared plus minus 2ab plus b squared. So therefore, this becomes x squared. 2 times 7 times x is 14x. We have a negative, so minus 14x. And then 7 squared is 49. That's how you arrive at it. Now, to solve this, we bring everything to the same side, which means, and I move this one this way, I get minus 2x and minus 16x. This one, minus 1, and I get 48. I want two numbers. The product is 48. The sum is negative 16. That makes it 4 and 12, both of them negative. So x minus 4, x minus 12. And there are two answers. X is either 4 or 12. You must check, especially if you raise it to the power that is even somewhere in the middle of your step. So if you put 4 in here, you get 2 times 4, which is 8, plus 1 is 9, which gives you 3, plus 7. 10 equals 4. No, that's not a solution, everybody. So F4 is out. Let's check 8. 2 times 12, 24, plus 1 is 25. Comes out as 5. Plus 7 is 12, yes. That's the answer. We just checked it, and we are done. And it's important to check. I can't emphasize this enough. X plus 2 quantity squared times x minus equals x minus 1 times x minus 6. So this is x squared plus 4x plus 4. Using the same a plus minus b quantity squared equals a squared plus minus 2ab in the previous page. So x squared, then 2 times x is 4x, and 2 squared is 4, and this is what we have. And when we move things around, here's what happens. First of all, you don't have to do anything about x squared, they cancel each other. Secondly, this moves this way, plus 7x. This moves this way, minus 4. You get 11x equals 2. X is 2 over 11. What about 4x plus 1 to the power of 5 thirds equals 32? How do you solve that? To undo the exponent, you raise both sides to the power of the reciprocal of 5 thirds, 3/5. So as you can see, this is 1, so it's 4x plus 1. We are using this format. A to the power of m to the power of n is a to the power of m times n. And so all we have to do, work on the right side. This is the 5th root of 32 to the power of 3. 2 cube it becomes 8. Subtract 1 becomes 7. Divide by 4. That's the final answer. So Please understand when you raise it to the power of 3 over 5, what it means. When you raise something to the power of 3 over 5, it means the fifth root of x to the third. That's the meaning of it. And because this is odd, you don't have to worry about it. We want to solve this one. 2 times 3x minus 4 to the power of 2 plus 3x minus 4 minus 1 equal to 0. There are two ways to do that. You can raise this to the power of 2 times 2, simplify and solve. Not a good idea. Can we do it that way? By all means. But there's an easier way, and that is by letting 3x minus 4 be something other than x. For example, let it be y. And so I hope you recognize if this is y, if this is y, this is y squared. And now you have a simple case of a quadratic equation. You find it by some method. Because 2 is a prime number, you can say 1 and 2. And because this is negative 1, you have no choice but to choose both one of them negative. So you have to go with plus 1 and minus 1. And the reason why is, take a look at this one. This gives you negative y. This gives you 2y. And the sum must be 1y. It works. So there are two answers. One of them is this, y equals negative 1. One of them, I hope you see that if you set this equal to 0, y becomes 1/2. Now, it's important to notice we are not done, meaning, okay, we got the y, but that's not what we want. We want the x. So replace the y with 3x minus 4 in both cases. Move this, make this 3. Move this. Make this 9/2. This one you divide by 3, you get 1. This one you divide by 3, you get 3/2. So 3x equals 3, 3x equals 9/2, x equals 1, x equals 3/2. What about here? First and foremost, notice this one, if you let it be any variable except x, like y, z, m, this one is the same thing to the power of 2. So if you choose x to the power of 1/3 to be m, then what you're looking at is m squared equals 2m plus 3. Since you want to solve this quadratic equation, take everything to one side. You want to, you can write it in this format. You want two numbers, the product is -3, the sum is -2. That would be -3 and +1. So m is either 3 or -1. Now, if x to the power 1/3 is m, what is x? Raise both sides to the third power, and x becomes m cubed. So x is 3 cubed, 27, minus 1 cubed, -1. And you really should check. We're going to solve here. There are two ways to do that. First of all, you move the negative 15 because you want to put it on the same side. Secondly, notice this is r squared to the second power. In other words, so having said that, you can rewrite it in this fashion. R squared, and then you want two numbers, the product. This must be the product. This must be the sum. So negative 3 and negative 5. So you could do that, or if it helps, you can write x equals r squared, and then you have it in this format. Okay, so let x be r squared. In other words, by substitution. So either r squared is 3 or 5. So r is plus minus square root of 3 here, plus minus square root of 5 here, and we're done. What about this one? There are two ways to do it, and we're going to do both ways. If you let b to the power of negative 1 be something other than b, x, y, z, then you should recognize b to the power of negative 2 is x squared. And now you can factor this. The way you factor it, you're dealing with number 6. You have to go with 2 and 3 or 1 and 6. And it's really not a lot to work on because 1, definitely 1 and 1, both of them negative or positive. So if you go with 2 and 3 and 1, both of them 1, if you go with negative, here's what happens, everybody. The product of these two, negative 3x, these two negative 2x, and you get the middle term. So x is either 1/2 or 1/3. This says x is 1/2, this says x is 1/3. So having said that, what is the relationship here? B to the power of minus 1 means 1 over b. And therefore, if 1 over b is x, b is 1 over x, meaning this means x and b are reciprocal of each other. So if x is 1/2, b is 2. If x is 1/3, b must be 3 over 1 or 3. That's the meaning of it. Now, the second method would be to multiply both sides by what? Remember, this is 6 over b squared. So multiply both sides by b squared. If I multiply by b squared, I get 6 here, minus 5b plus b squared. The right side doesn't change. I highly recommend you try this method as well. So try this one, make sure that gives you the same answer. A fitness club charges $20 as a monthly access fee and $2 per day of use. Express the monthly costs C in terms of daily usage. So we have to choose a variable such as X to represent the number of days. So if X represents the number of days, C of X is of interest to us. We have a fixed cost of 20 and 2 per day. So 2X plus 20. Please understand this is the slope in essence. And think of Y equals MX plus B. This is M. This is B. Instead of Y, we are going to use C. What will the monthly cost be if the club is used for 15 days? Plug in 15. We get 30 plus 20, 50 bucks. Again, Y equals MX plus B, and this is the slope, the average rate of change, and of normally Y with respect to X, in this case, B with respect to X, and B is the constant $20 a month. If the length of a rectangular room is twice its width, and its perimeter is 90 meters, find the dimension of the room. So we have a rectangular shape. Here's the width, here's the length, but the length is 2 times W. So if the length is 2 times W and the perimeter, which is 2L plus 2W equals 90, so this says 2L plus 2W is 90. Now we can solve this by simply replacing the L with 2W. So if I replace the L with 2W, I get 2 times 2W or 4W. 4 and 2, 6W is 90. And the width becomes 15. The length is twice that, 30 meters. And you check. If you add them up, you get 45 times 2 is 90, so you can check easily.